Bioplastics refers to the material that derived from biological sources. So the most popular bioplastic is polylactic acid. When you put into room temperature, into the soil, it doesn't degrade. We made it degradable in the room temperature. That's a big deal. So this material, we think, can be one of the answers to the plastic challenges we are facing today. In India, people actually use actual leaves to pack the food, and then that serves as a packaging material. So we were thinking, okay, leaves has multiple layers. Maybe we can do a similar type of design. If we can learn from leaf, do a design that can make it totally biodegradable, that means the most abundant bioplastics does not need to go to the compost. You can just make packaging material out of it. It can degrade in the environment at room temperature anytime. Impermeable to air, much stronger, can go to the trash can without any problem. Relatively low-cost packaging material. You can imagine this is for food packaging is one of the early applications. And then you can expand that. When you build a plastic bottle, you need another type of processing. We're working on it, so the next stage is a plastic bottle. So we have a game plan on each step, how we expand the product. Energy, Environmental, and Chemical Engineering department is a very strong department in WashU. Dr. Zhang is working on protein-based plastics. He is also working on how to make the fermentation process more stable so that we can reduce the cost of fermentation.
Research program currently funded by DARPA. Our goal is to develop a new technology that would enable not only us, but many other research groups as well as industrial partners to have a more efficient fermentation process and technology. Fermentation process is a process where we grow microbes in a way similar to the breweries. These microbes can produce some useful products for us. In this particular case, we want the microbes to produce a plastic for us so that we can use these plastics to replace current petroleum-derived plastics to save the environment. Because right now, majority of the plastics are made from petroleum. Using a process that is high energy demanding will have the right properties for our application. The manufacturing process would not rely on a huge amount of organic solvents or high temperature. That would also reduce the energy consumption. Because those plastics are made from biological origins, they all share a common feature, which is they are all biodegradable.
We want to produce bioplastics cheaper. So we use fermentation. We actually produce PHA, PLA from carbon dioxide. From different type of waste, we produce plastics. We control the plastic structure so that we have new functionality, addressing all of these challenges. Next generation bioplastics